Today we are going to continue on with our honors work looking at day 4, and we'll start with a which one does not belong situation. So there are 4 equations here. They're all numeric. You're trying to figure out which one doesn't belong. And depending on how you're thinking, it could be any of them. So if you'll just take a moment and highlight the one you think doesn't belong, and after you write a reason why, and after you've done that, you can come back to the video. There is not a correct answer per se for which one doesn't belong. I will share a little bit of reasoning. Maybe you said the first one was the only one that had addition, or maybe you said the second one was the only one that had multiplication, or the second one was the only one that dealt with the number 35 indirectly. Maybe you said the third one is the only one that had one number on one side of the equation. There could be lots of different thinking happening here. This is the only one that isn't true because -2 is not equal to 2. I really need to put that in there. I don't feel comfortable leaving that as a lie. So, moving on, we are thinking about solutions. We are going to look at each of these and decide, is it true for all values or true for no values? In other words, always true or never true. So we're going to determine that for each of these. So in order to solve these problems, I'm going to work them out step by step. So right here, n equals n. So whatever n is, it equals n. Let's say n 7. 7 equals 7. True. Let's say n is -3. -3 equals -3. True. This is actually true for all values. So when we end up with the variable equals the variable, or a number equals the same number, like 3 equals 3, then that's when it's true for all values. So this is a truth. This is when I say it's a lie. It's never true. So we will find an example of that as we move onward. So let's go ahead and look at this one. I can probably... Okay. So what I'm going to do is copy it. I usually put a little tail on my T's so that they look like T's instead of plus signs. Okay, so here I can distribute, and I get 2t plus 6 equals 2t plus 6. That's exactly the same. That is always true. I could solve a little further if I wanted to, and I could end up with 2t equals 2t. Then I could divide each side by 2 and get t equals t if I wanted to. But at this point I can really see they're exactly the same, and I can select true for all values. Okay, I'm just going to switch colors. That way I can stay somewhat organized. We'll move on to the next one. Copy that one. Let's get my paper over. Okay, 3 times the quantity n plus 1 equals 3n plus 1. So here I could distribute and say 3n plus 3 equals 3n plus 1. That is not the same. But just to kind of prove it to myself, I can work a little further. What if I subtracted 3n from each side? 3 equals 1. That is not true. Therefore, this is never true. Okay. Fold this paper. Next question. 1/4 times the quantity 20d plus 4 equals 5d. So let's work this out. 1/4 of 20d is 5d. 1/4 of 4 is 1. Okay, what if I subtract 5d from each side? I get 1 equals 0, which is a lie, or true for no values. Next, looks like we have some like terms to combine. I'm going to go ahead and do that. 5 minus 9 is negative 4 plus 3x equals, again, combining like terms, negative 10 plus 6 is negative 4. So I can see right now this is true for all values. But just to be consistent with what I have been doing, let's eliminate the variable and get negative 4 equals negative 4. And that is true. Now I have this problem. 1/2 plus x equals 1/3 plus x. Let's just eliminate the variable. 1/2 equals 1/3. Lie. Never true. Couple more of these. So the next one, we'll start out with multiplication. So it's all multiplication. Negative 6 times negative 3 is positive 18 times y. That would be 18y equals 2 times 9 is 18 times y is 18y. Okay. I can see that's exactly the same. I could divide each side by 18 and y equals y. Okay. True for all values. One more. I think I can fit it here. Switch colors. V plus 2 equals V minus 2. So I'm going to eliminate the V. And I get 2 equals negative 2. That's a lie. So that is true for negative. Now, write the other side of the equation so it is true for all values. So one way I could do that, I could just distribute here and I could say 6u minus 12 plus 2. I could also kind of simplify that and put 6u minus 10. There's lots of different ways I could do it. These are probably the two most common. Now, if I want to make it so it's not true, so it is true for no values, all I would need to do is put like 6u plus 4. Anything besides minus 10, anything that did not simplify to minus 10 would work. Or anything that wasn't 6u. So I could use 8u minus 10. So as long as it's not exactly this value, whether it's written this way or not, as long as it's not that value, then it is not true. So this next section talks about consecutive numbers, which we have talked about several times at this point. This is just the definition, and then how many sets of 2 or more consecutive positive integers can be added to obtain a sum of 100. So the purpose of this is just to see how many solution sets are possible when it's none or all solution sets. So I don't love this question. The intent is that you would, practice and just kind of guess and check to see how many sets of 2 or more consecutive positive integers you could add to get 100 as your sum. You're welcome to pause this and work through that sum. I'm just going to show you the solution and then move on. So there are 2 solution sets, 2 solution sets, and they're each listed here if you want to make a note of that. Moving on, we're going to complete these so that it's true for all values of x. So basically I'm distributing here and just trying to understand that if I have 2 sides of an equation that have exactly the same value, then I can say that's true for all values of x. That no matter what x is, it's always true. And you're going to have, let's see, a 2 here because 3 times 2 would give you 6. And then here, the opposite of 2 opposite of 2 minus x is negative 2 plus x, which is x minus 2. Okay, then this one looks like I've got minus 2, which comes from this part here. And then on the other side, I would be doing 15x minus 5, or divided by 5, which would give me 3x. So 3x is that value, and then here in the next section I'm making it so it's true for no values of x. So I could use any number other than the 2 I used to make it always true, and then it's never true. So again, any number other than the 2 that I used to make it true, and it's never true. And anything other than the 3x I used to make it always true, and it's never true. So how do we know that an equation will be true for all values of x or for no values? So for all values, you're going to end up with something like x equals x or 2 equals 2. And then you know that it's always true. For no values, you would end up with something like 7 equals 6, which is never true. And then you know that there are no values for this equation that you have.